Chapter 6 is on inverse circular functions and trig equations, and we're going to start off in 6.1 with inverse circular functions. The first part of this section, we're going to review inverse functions, and then we're going to go over inverses of the trig functions. Let's start off by reviewing what a function is. A function f is where every element in the domain corresponds to one and only one element in the range. If we look at number 1, it says if a point AB lies on the graph of f, then there is no other point on the graph that has A as a first coordinate. Let me give you an example. If 1, 3 is on the graph, then no other point that starts with a 1 will be on the graph. So no other point, let's say 1 comma something, is on the graph. If 1, 3 is on the graph, then you're not going to have 1, 2 on the graph, or 1, 0. You can never have some other value for y if x is 1. Now, other points may have B as a second coordinate. However, because the definition of function allows range elements to be used more than once. Let's go back to this one. If 1, 3 is on the graph, okay, we can't have another point that starts with a 1, but we can have something 3 on the graph. If the point 1, 3 is on the graph, then 2, 3 could be on the graph, or 5, 3 may be on the graph. You could have different values of x for the same y, but you can't have different values of y for the same x for it to be a function. These 2 points refer to functions. Now what we're going to do is look at specific functions, and these are called one-to-one functions, and that is where each range element is used only once. Coming back to here, if we have some other value 3 on the graph, then it is not one-to-one. So in order for it to be one-to-one, each x has only one y, and each y has only one x. Do you remember what the vertical line test is? I'll just make a little example here. Vertical line test. We use that to test if the graph of something is a function. So suppose that we have the graph of a parabola. Is that a function? Yes. So we use this vertical line test to test whether it's a function. And this is a function because it passes the vertical line test. If you take any vertical line, you see how any vertical line that you draw will pass this graph at only one point. So that's why it is a function. If we have something like this, it's also a parabola. Does that pass the vertical line test? Well, we could draw a vertical line, and do you see how it hits the graph at more than one point? And so that means it's not a function. So it's not a function. So that's the vertical line test. So it was a little review of that. Now what we're going to do is we're going to look at only functions. So this first one's a function. And then we're going to determine if it's one-to-one. So the way you test if it's one-to-one is you use the horizontal line test. The horizontal line test, if you have something like a parabola, which is a function, is this function one-to-one? Well, if we can draw a horizontal line and it passes through this graph at more than one point, that means it's not one-to-one. So this is not one-to-one. An example of another function We could have something like a straight line. It's a function, it passes the vertical line test, but does it pass the horizontal line test? Is there any horizontal line that passes through the graph at more than one point? No, there aren't any, so this is one-to-one. So yes, it's one-to-one. If a function is one-to-one, then it has an inverse. And do you remember how inverse functions, all you do is you switch your x and y values. So if xy belongs to f, then you switch the x and the y and you get f inverse for all the points in the function f. Be careful though, we don't want to confuse the negative one when we use this notation. F inverse is not f to the negative one. The symbol f inverse of x represents the inverse function of f. It's not 1 over f of x. Okay, let's go on to a summary of inverse functions on the next page. In a one-to-one function, each x value corresponds to only one y value. And each y value corresponds to only one x value. If a function f is one-to-one, then f has an inverse function, f inverse. The domain of f is the range of f inverse, and the range of f is the domain of f inverse. So the domains and ranges are switched. That is, if a point AB is on the graph of f, then the point BA lies on the inverse. The graphs of f and f inverse are reflections of each other across the line y equals x. For step 5, I'm going to go ahead and write these steps and then give you an example on the side at the same time to make sure you really understand this. Step 1 is to replace f of x with y and interchange x and y. So what we're doing is we're going to find f inverse from a function f of x. So suppose that we start off with the function f of x is equal to the square root of x minus 1. The first step to find the inverse is to replace f of x with y and then interchange the x and y. That's actually more like 2 steps. Step 2, solve for y. If we solve this for y, I first need to get rid of the radical. I'm going to square both sides, so we'll have x squared is equal to y minus 1, and then add 1 to both sides, so we have x squared plus 1 is equal to y. Step 3, replace the y with f inverse of x. I'm going to replace the y with f inverse of x, and I'll just switch this around so it makes more sense. So we have f inverse of x is equal to x squared plus 1. So I found the inverse, but I do have to be careful because of the domain and range. Let's go ahead and draw the graph of this, and then I'll add one more thing to that. Going back to the original function, if we graph f of x is equal to x minus 1, then if I plug in 1, I'll get 0 for y. Plug in 2, we get 1 for y. And if I plug in 3 for x, now let's plug in 5 for x. That's nicer. 5 minus 1 is 4. Square root of 4 is 2. This is the graph of f. For the graph of f inverse, if I plug in, say, 0 for x, then I'll have 0 squared plus 1 is 1. If I plug in 1 for x, 1 squared plus 1 is 2. And then if I plug in 2 for x, 2 squared is 4, plus 1 is 5. 5. Then we have f inverse. This f inverse actually this is only part of the graph. The rest of it is where x is negative. But do you see how that would not be part of the inverse function of f? Because here, do you see what the domain is? Coming back to f, the domain, the smallest value that x can be is 1. So it goes from 1 to infinity. And the range, the smallest value that y is going to be is 0. Well, when we find the inverse, we're going to have to restrict this domain, because for the inverse, the domain is the range of the original, so that's 0 to infinity, and then the range is from 1 to infinity. We have to make sure that when we state this inverse, that we also have to say that x has to be greater than or equal to 0, because that's part of this domain. This is the whole inverse there. We look at the graph, we're just restricting x to be greater than or equal to 0. The graphs of f and f inverse are reflections of each other across the line y equals x. If I graph the line y equals x, and I'm going to just make this a dotted line, plug in 0 for x to get 0 for y, plug in 1 for x to get 1 for y. See, the x and the y values are all the same. If I draw this, do you see how the graphs of f and f inverse reflect across that line y equals x? Just to review one more time, if you have a function and its inverse, all you're doing is switching the x and the y values. So you choose, say, the point 1, 0 on f, then 0, 1 is going to be on f inverse. On the original function, we have 2, 1. So 1, 2 is on the inverse. So we're just switching the x and the y values to come up with the inverse. There are two ways to see how to find the inverse. And step 5 is an algebraic way that you can follow these steps. If you have an equation, you follow those steps to find the inverse. If you're trying to find the inverse with a graph, you can just switch the x and the y values.